We've talked about absolute value equations. Now we're going to talk about absolute value inequalities. So let's start off with a really basic idea. Absolute value of x less than or equal to 9. Now we've already talked about how if this were just equal, absolute value of x equals 9, that means that it's a distance of 9 from 0. So let's look at our trusty little number line. Here's 0. If I want a distance of 9, I know that it could either be positive 9 or it could be negative 9. But what about this inequality business? It says less than or equal to 9. So that means it has to be closer than or equal to a distance of 9. So that's going to be everything in here. Anything between the 9s would actually work. So what about the endpoints? It's less than or equal to. And like you've learned before with inequalities, if it's equal to, that means it's included. So this is a big solid dot. Big solid dot here. And if it's not equal to, then it's a hollow dot because it's not included. And we'll deal with another one of those later. So if I wanted to actually write my solution, this is the graph of my solution. To write my solution, there's two different notations we can use. We can use interval or we can use inequality. So if it's interval, it's negative 9 to 9. If it's inequality, x is greater than or equal to negative 9, less than or equal to positive 9. And either one of those is just fine. We can also look at it in terms of an XY grid. So if I look at that same equation, absolute value of x less than or equal to 9, and I look at it on an XY coordinate grid, that means absolute value of x is one of my equations, so this would be like y1. This would be y2. So this gives me absolute value of x is something like this. It's x in one direction, negative x in the other. So it's this little v. And then y equals 9. So let's say that that's right here. Let's say that that's 9. And I want to know where is this equation less than or equal to 9. So that's going to be, again, anything in here. What if I have the different inequality? What if I'm looking at absolute value of x is greater than, let's say, 3? If I want greater than 3, then that means the distance from 0 is greater than 3. On my number line, here's 0. I know a distance of 3 would be either 3 or negative 3. And I need the distance to be greater than that, so it needs to be further away from 0 than that. So that's going to be on this side or on this side. Notice I graphed this one a little differently. I did the arrows up above the actual number line. That's just because it's a little easier to read on a graph and it looks less sloppy than if I were scribbling everything. And I have open circles because it's not included. So you can do it up above the graph like that. You can squiggle on the actual number line if you want. You can do it in a different color. There's a lot of different ways that you can graph, and all of them are perfectly fine. So this is my solution for this. How do I actually write it in a solution format that's not just a number line and a graph? I have interval notation, which is negative infinity to negative 3, not included. Union 3 to infinity, because I have two sections of my number line, I have two sections of my solution. Or again, I could do it in inequality notation, so I could say that x is less than negative 3 or x is greater than 3. Remember, these are ors because they're disjunctions. They're going in opposite directions. They don't actually connect to each other. And I can also look at this on an XY grid as well. So move that up. So absolute value of x, something like that, and 3. And I'm looking for a distance, or not distance, I'm sorry. I'm looking for a y value that's greater than 3. So where is absolute value of x greater than 3? Well, it's here, and it's here. So again, it looks a lot like our number line. There's two different sections of our solution. And of course, these are going to get a little bit more complicated. It's not just going to be absolute value of x is greater than or less than some number. They're going to be a little bit more algebraic. But what you might notice is if we look at the two different scenarios, I'll put this one back up here. If it was less than, it was between. If it was greater than, it was outside. So these are and or situations. Okay? And there's a really, really cheesy way to remember whether it's an and or an or situation. You can laugh all you want, but it actually works. So if it's less than or less than or equal to, it's an and, less than. If it's greater or greater than or equal to, it's great or, yes, I realize that it's not spelled correctly, but it'll work. Less than, greater. Okay? So it's important to know whether it's an and situation or an or situation because you won't always know from the answers that you get. Sometimes it can be a little bit tricky. So let's take a look at a couple of examples that are a little more complicated. Let's look at absolute value of x plus 3 is less than 12. Well, I can't just go ahead, I can't graph every single thing that I come across. That's not going to be efficient, and sometimes it's going to get confusing, so we need to look at it algebraically. Just like with our equations, we had two scenarios. If this were an equals instead, we would have done x plus 3 equals 12 and x plus 3 equals negative 12. Same type of idea here, one difference. So I have this, and I have this, but the difference is the sign is going to flip. And the reason the sign is going to flip is if we look back at one of our first examples here, here are my two cases. I have x is less than or equal to 9, and x with relation to negative 9. Well, it's not less than negative 9 because technically less than negative 9 is going to the left. It's greater than or equal to negative 9. So this sign here had to flip whenever I made it negative. Okay? So in your negative case, you have to flip the sign. And then I can go through and solve these, and it becomes pretty easy. So x is less than 9. X is greater than negative 15. Is this an and or an or situation? Well, it's less than, so it's and, which means I should be able to write these as a combined inequality. Okay, and the symbols are always going from the least to the greatest. So these symbols always face this direction in a combined inequality. If you can't write it as a combined inequality and it's supposed to be an and, then you have a problem. And we can graph this as well. Negative 15, 9, don't worry about all the tick marks in between, that's just waste of time. And it goes right here. Open circles because they're not included. Okay, so this can be your answer, or if you like interval notation, negative 15 to 9 this direction. Let's do another one that's still a little more complicated than that. Let's do absolute value of 2x plus 5 minus 3 is greater than or equal to 17. Just like with absolute value equations, we have to get the absolute value all by itself. So I want to add 3 to each side. So it's greater than or equal to 20. Now I have the absolute value by itself. Now I have my two cases. So I have my positive case, and I have my negative case. And don't forget to flip that symbol. Otherwise you're going to end up with a really strange little answer. So 2x is greater than or equal to 15, which means x is greater than or equal to 15 halves. You can just leave it as a fraction, or if you really want to, you can put it as a decimal. It doesn't matter. And let's solve the other one. I don't know why I did that. There we go. X is less than or equal to negative 25 over 2. Is this an and or an or situation? Well, it's greater, so it's greater. I'm going to put some ors in here. So it's or, that means it should be a disjunction, and there should be two sections to my graph whenever I graph this. So let's look at the graph. Negative 25 halves, 15 halves. Again, if you want to put that in decimal, that's negative 12.5 and 7.5. Doesn't really matter. So x is greater than 15 halves, greater than or equal to, so it's solid, or less than or equal to 25 halves. And you can leave it as an inequality, or if you want to, you can do interval notation. This time it's with a bracket because it is included. And those are your two possible intervals for the solution for that absolute value inequality. And we have one more. This one's a little bit of a special case. It's kind of tricky. Let's look at 3 times the absolute value of 4x minus 1 minus 6 is greater than negative 12. Again, we're going to isolate the absolute value first. So if I add 6 to the other side, I have negative 6. Absolute value of 4x minus 1 is greater than negative 2. Now I can do my two cases and decide whether it's an and or an or. So one case, 4x minus 1 is greater than negative 2. Second case, 4x minus 1 is less than, flip the sign, make it negative or negate it. And is this an and or an or? It's greater than, so it should be an or, greater. Now I'm going to go through and solve. If I add 1, I get 4x is greater than negative 1, so x is greater than negative 1/4. Add 1 over here, I get 4x is less than 3, so x is less than 3/4. And this is supposed to be an or. So this means that when I graph this, I should get two distinct sections for my answer. So let's take a look at what this graphs as. Move this up. So, negative 1/4 and 3/4. Here's negative 1/4. Here's 3/4. If it's greater than negative 1/4, so it's here, and it's going to the right. If it's less than 3/4, that means that it's here, and going to the left. Uh-oh, that looks a little bit different. So if I look at all the numbers where there's a line here that are being graphed, is there any number that's not graphed? You might say, well, negative 1/4 because it's got an open circle. But what about this line that goes straight through it? So negative 1/4 is an answer. So is 3/4. In fact, every number that you can think of is an answer. So for this one, it's not negative 1/4 to 3/4 or, you know, these actual inequalities here. That's not the way you want to write your answer. This answer, all real numbers. Remember, this funky little r means real numbers. And you can write it like this, or if you want to, you can do interval notation from negative infinity to infinity. Now, there is a way that we could have figured out earlier that this was going to be an all real numbers answer. So let me give you a second. Look at the steps that we had so far. See if you can figure out which step tells me that this is all real numbers without having to actually go through and solve for x. You got it yet? Alright, well, the one that tells me that it's all real numbers is actually this one right here. This says absolute value is greater than negative 2. Well, what do we know about absolute values? We know that absolute values are always positive. So this is saying a positive number is greater than -2. This is always true, no matter what. Always, always, always true. So because that's always true, we could have stopped up here and recognized, hey, this statement is always a true statement. That means it's all real numbers. What happens if you get to a situation and you say, that's never true? What if this were less than? Well, if I had it to where it were less than, what kind of numbers are less than -2? Negative numbers. So can a positive number ever be less than -2? No. So this statement is actually never true. And in this case, our answer would be no solution. So you need to actually think about what these equations are saying. Decide if it's and or. That's going to tell you what your solution actually looks like. And how to graph it and how to write it.